Hey everybody, my name is Tam N. I'm a math tutor here at Chegg, and today I'm going to be talking about the polar coordinate system. So with our normal coordinate system, what we call the Cartesian coordinate system, we have an x and a y, right? And how we plot the x and y's, let's say we have a point 3, 3. Well, simply we go, we find where x is 3, it's going to be this line here. Alright, I'm going to draw it in red where x equals 3. And then we find the line where y equals 3. That's going to be right there. And then you find where these two lines intersect. And that's going to be right here. Should make the line a different color. I thought I did. Right? Normally that's not how you think when you plot points, because it comes so naturally to us plotting on the x and y coordinate system. But that's really what you're doing, right? You're finding where the line x equals 3 and the line y equals 3 intersects. So let's take a look at a coordinate system where we don't rely on x and y. And that's going to be the polar coordinate system, where instead we rely on r and theta to plot our points. So r is going to be the radius, or some people like to think of it as the length. And theta is going to be the angle. Right, if you recall, right here is the angle 0. Right around here is pi over 3, pi over 4 is diagonal. Then we've got pi over 6, pi over 2, and so forth, right? This is pi, 3 pi over 2, 2 pi, and it goes on like that for quite a while. Alright, so let's say I have a unit circle. Alright, in this circle, we're going to pretend like it's the unit circle, alright? So we know it has a radius of 1. Right here's 1, right here's 1, negative 1, negative 1. And we want to plot the point. We want to plot the point 2 over radical 2. No, I'm sorry about that. I want to plot the point square root of 2 over 2. And pi over 4. So what that's really saying is that we have an angle pi over 4. I'm going to draw that here. It's about there. And we want to find where that angle has the length square root of 2 over 2. And since it's the unit circle, we know that's going to be right there, right? So that's basically it. We have our r here, right? If you draw the distance from the origin to this point, it's going to be square root of 2 over 2. It's kind of hard to write that here, but you guys know it's square root of 2 over 2. And then we have this angle here, which is pi over 4. So that gives us our coordinate pair, square root of 2 over 2, comma, pi over 4. Let's take a look at some more examples, and let's say we're not going to use the unit circle this time. It's just going to be free floating. And let me delete this circle. Let's say I have a point, I don't know, 4, 0, right? And this is in terms of r and theta, right? This is not x and y. So we know that the angle is going to be 0, right? And that's going to be this line here, right? It's not going to be here, anywhere else. It's going to be this line here. We want to find where the length is 4. So 1, 2, 3, 4. Angle is 0. And we get our point, 4, 0. How about, well, that's not equal to. I want to plot the point now. -4, 0. So what do? Same concept. It's on this line, 0, right? It has a length of -4, though. So what we're going to do is we're going to flip it over to the other side, right? So this is the angle 0, this line here. And then it has a length of 4. However, it's negative. So we're going to flip that all the way over here. And this is -4. Whoops. Zero. This is 4, 0. Right, one more thing. Let's say we have r and theta, where r is 4, theta is going to be pi. Alright, so we have, this is angle 0, right? This is pi over 2, pi. So pi is going to be from here on out, right? This line that I'm tracing right here. It's going to have a length of 4. 1, 2, 3, 4. That's going to be the same point, right? So that point's also going to be 4 over 4 comma pi. So now we notice something unique about the polar coordinate system. And that's the fact that points are not unique. Alright, so what that means is one point can be expressed several ways, right? If we had an XY coordinate system and we had a point there, you can only express that point one way. That's going to be, this point that I just drew is going to be 2, 3, and there's no way else you can really express that. I guess you can try to put fraction stuff, but overall it's the same number. These are not the same numbers, but they are the same point. Another way that you can see that they're not unique is that you can add 2 pi to any angle and it'll be the same thing, right? So this point that I just drew here can also be represented as 4, 3 pi. Well, that's about 3. Right, because 3 pi, you're just adding 2 pi to pi. So it's going to make a full revolution. Nothing's going to happen. Right, and that's some pretty interesting stuff about the polar coordinate system. And the reason that we use the polar coordinate system is because sometimes we have problems that deals with circles. Right, you guys have seen that before. X squared plus y squared equals a radius. And sometimes it's just easier to work with a coordinate system designed for that circle. And you guys will learn a lot more about it if you ever have to integrate circular regions. Alright, my name is Tam N. This was a lesson on the polar coordinate system. I hope to see you guys next time.